Okay, good morning everyone. So in this video, my goal is try to show you an example of a rational function problem. So assuming that you just look at the Softchoke problems, you participated the activities in the Desmos, or you read the PowerPoints, or you know somehow what rational functions are. You have the information about that. So here's the problem. Use the function below to answer the parts that follow. If a requested quantity is undefined, please write the any. So this is our rational function. F of x, 2 times x minus x times x plus 1 divided x plus 1, x minus 3. Okay, so immediately we see that this x minus 1 and x minus 1 can be simplified, and we can write the function in the simplified form as 2 times x minus 6 over x minus 3. So we're going to keep using this red form, or the simplified version of the function, for certain questions below. All right, we're going to go ahead and start with x-intercept. So x-intercepts mean y equals 0. However, rational functions will be equal to 0 when numerator equal to 0. Okay, because we do not want the rational function denominator equal to 0, then in that case rational function will be undefined. So we're going to look at the numerator of the simplified one, right? And then we see that we have I'm on my screen. To that, then x will be equal to 3. So then the x-intercept will be 3, 0. Okay. Now y-intercept. Y-intercept means that, okay, let's use a different color, maybe. It means that x equals 0. Right? So then I'm going to use again my simplified version, and I'm going to plug in zeros for x. So 2 times 0 minus x, 0 minus 3. Be careful at that point. Do not rush. Don't make everything equal to 0. Just calculate the value. 0 minus x is negative x. Negative x times 12 is negative 12. You have negative 3 at the bottom. So then we are going to have 4. So then y-intercept will be x equals 0, y equals 4. Okay. Now determine the domain of a function. Now when we're looking at the domain, we need to consider the original function, because we've done some simplifications there. Accidentally, we might forget that simplification. X plus 1 is x plus 1. However, we need to take it into consideration. So, domain of the rational function, check the denominator, because we do not want denominator will be equal to 0. On the denominator, we have x plus 1 and x minus 3. From there, then we're going to write down x minus 1 equal to 0. X minus 3 equal to 0, x cannot be equal to negative 1, x cannot be equal to 3. Okay, now we need to put it into an interval form. You cannot leave it like that, right? So how are we going to write it down? Negative infinity, negative 1, union, negative 1, 3, union, 3, infinity. Okay. That's the domain of the rational function. All right, next question. Determine the equations of any vertical asymptotes of the function. Okay, the vertical asymptotes. Okay, for that you need to look at the simplified version, because once we simplified x plus 1, x plus 1 there, we actually created the whole. If there is a simplification. So in the vertical asymptote case, we do not consider the whole. So we're just going to look at the simplified version. What do we see there? X minus 3. Then vertical asymptote is just a protector for the function, right? That will be the vertical asymptote. Hence the relationship between the vertical asymptote and the domain here, right? Okay, so that's the VA. Now equations of horizontal asymptote. So equations of horizontal asymptote, we have three cases. One, numerator and denominator leading coefficients have equal degree, which means I do have x squared on numerator and I do have x squared on the denominator. Then we divide the leading coefficients. Okay, so this is case 1 though. Case 2, numerator higher degree than denominator. All right. Then horizontal asymptote doesn't exist. Okay, the third case, denominator higher degree than numerator, then horizontal asymptote will be y equals 0. Remember, the horizontal asymptotes, we're talking about y equals to something. Vertical asymptotes, we're talking about x equals to something. Okay, so those degrees that I'm mentioning here, the leading coefficient degrees. All right, then if you go back and look at the equation, we do have some x squared, or even in the simplified form, right? Some x, first degree on top, first degree at the bottom, and the leading coefficient here will be 2. The leading coefficient at the bottom is 1. So they do have equal degrees, and the division of those degrees will be 2. So then horizontal asymptote here will be y equals 2. Okay. Determine the location of any holes. I just mentioned that up above, once you make the simplification, you're creating a hole, and that hole will be important for you when you're writing down your domain and your vertical asymptote. So that hole is not going to be considered as a vertical asymptote. That's an important point. But that hole need to be implemented in the domain. So the holes will be here, x plus 1 equals 0, so x equals -1. All right, so now x equals -1 is the value of the x for the hole, but they're asking hence the location. So what would be the y value? That's what's important for us. We need to do that also. So we're gonna go back to the simplified version again, and we're gonna plug in -1 there. So 2 times -1, -6 divided by -1, -3. So with the simplified version, -1, we're going to have -14 over 4. So y value will become 7 over 2. -14 over -4. Yeah. So then the location of the hole, answer to that problem, will be -1, 7 over 2. Okay, usually, this is a common mistake. Students leave the answer here, but it's incomplete. You need to go ahead and plug that value into the function, find the value, y value because we're asking the location. And the other common mistake is with the domain. Okay, you might skip to include the hole in the domain, or you might include the hole as a vertical asymptote here in the vertical asymptote question. So in this question, parts B, C, and E, you need to pay close attention. Okay, let's continue. So sketch the graph of a function. All right, let's put the asymptotes first. What did we have? X equals 3. So 1, 2, 3. All right, I'm gonna put my dotted line here. Okay. And horizontal asymptote y equals 2. Okay. So I know that the functions are not going to be crossing the asymptote, right? So I could be either this area, this area, this area, and this area. All right. So then I'm gonna put my x-intercept, which is 0, 6 here. I'm sorry, 6, 0. My y-intercept 0, 4, which is there. Okay, so then I need to eliminate the sections. Since I do have my x-intercept and y-intercept there, I know which sections I'm at now. Okay, and then we can put the hole also, because we have a hole, -1, 7 over 2. So -1, 7 over 2, it should be somewhere, that's this wide, so it's a little bit big. I think here, but that's a hole. Okay, so that's 7 over 2, and that's 1, so that's the hole. Okay, now we can draw it. So we're coming from here, passing through there, and then we're coming from down. It's the asymptote there. Voila, it's done. Okay, so thank you for listening to me. I wanted to share this example of a solution rational function problem. Again, the parts that usually students might make mistakes. The location of the hole, you need to give it with the y coordinate. You need to plug in that x value into the simplified function form. Be careful about your vertical asymptote. You don't include the hole. Vertical asymptote is an equation, and it's an equation x equals 2. Horizontal asymptote, it's an equation y equals 2. Be careful with that. And the domain of the function, be careful you're including vertical asymptote and the hole. All right, hope it helps. That's all about me. See ya.